fait quelques réglages, mais a priori, on est bien en diffusion au niveau Chromecast avec les personnes qui sont connectées. Et nous sommes aussi en direct sur YouTube de ce côté-là. Donc j'essaierai pendant la conférence d'envoyer, de tweeter le lien correspondant. Dessus, on y va, on est parti. Alors par contre, il faut que je abonne l'écran. Voilà. Au niveau de la soirée, donc je vais vous présenter rapidement les news du Jug et très peu de news Java, comme je l'ai dit, je vais faire court. Et puis je vais notamment laisser la main à Geoffrey, que je remercie d'être venu et de se libérer ce soir pour pouvoir assurer la session au niveau du BordeauxJUG. Et donc on pourra faire la conférence. Et puis à la fin, vous aurez la possibilité, pendant la session, vous pouvez interagir avec le chat pour pouvoir éventuellement poser des questions si vous le souhaitez. Et puis après, vous pourrez interagir avec lui en direct en faisant signe. Dans l'interface, vous avez posé une question et à ce moment-là, je pourrais vous inviter pour pouvoir directement poser la question au niveau de Geoffrey. Naturellement, étant donné que notre speaker est anglais, les questions sont majoritairement prévues en anglais si possible. Voilà. Sinon, je tiens à remercier au niveau de moi et le BordeauxJUG de remercier le projet Jakarta AI qui nous permettent d'organiser ces types de sessions au niveau d'en ligne pour pouvoir faire continuer l'activité du Jug, de pouvoir nous retrouver virtuellement en attendant de pouvoir partager une bière, un verre avec vous et pouvoir échanger comme on a l'habitude de le faire, mais ça nous permet de garder le lien et de continuer à pouvoir échanger sur la communauté Java. Et c'est un très très beau geste de la communauté de solidarité de la communauté Java. Donc c'est bien de pouvoir le préciser. Au niveau du Jug, des news du Jug, vous avez naturellement le site web qui est à disposition, qui permet de vous tenir au courant sur les différentes sessions qu'on peut avoir. Si on pourra mettre aussi les présentations, et vous avez notamment l'onglet speaker qui permet d'avoir des informations sur les personnes qui viennent au niveau du BordeauxJUG. Vous avez aussi en place un forum qui est à votre disposition de ce côté-là, qui vous permet d'échanger. Alors on s'en sert, nous, au niveau du Jug, pour la communication des annonces, mais ça peut être aussi un moyen de pouvoir échanger sur des sujets divers et variés, concernant naturellement la communauté Java. Mais voilà, ça peut être un moyen de faire vivre la communauté bordelaise Java. Nous avons les chaînes YouTube. Donc là, comme je vous ai présenté, nous sommes aussi en streaming live avec YouTube qui est aussi disponible. Donc ce qui va permettre que cette conférence sera disponible via Crowdcast et sera aussi disponible via YouTube. Donc ce qui permettra de compléter toutes les sessions comme on a pu les avoir en début d'année. Le JUG, c'est une association qui est ouverte à tout le monde peut participer, même dans ces conditions, dans le contexte actuel, c'est complètement ouvert, n'importe qui peut venir et assister à les conférences, donc c'est vraiment l'état de principe. Par contre, effectivement, c'est une association et derrière, on a besoin d'avoir des membres pour pouvoir avoir des partenaires et relayer en disant qu'on est existant, c'est le groupe de personnes. Donc, n'hésitez pas, si vous n'êtes pas encore membre, à aller sur le site, vous avez un lien devenir membre. Et en tout cas, j'en profite aussi pour remercier les personnes qui sont membres du BordeauxJUG officiel et qui renouvellent année après année leur souscription, qui montre effectivement l'intérêt de cette communauté. Sur le programme par rapport à juin, effectivement, vu les circonstances, on n'a pas forcément très anticipé au fur et à mesure, mais on aura l'occasion d'annoncer dans les canaux habituels les prochaines sessions qui pourraient venir. Après, si vous avez des conférences, des idées sur des conférences ou des quickies, n'hésitez pas à venir nous voir. Vous avez une adresse mail, c'est le team@bordeauxjug.org. Vous nous envoyez un mail avec les informations dessus et avec vos idées, que ce soit une conférence, que ce soit un quickie, on peut parfaitement le mettre en place, même si c'est dans un contexte comme ici de conférences en ligne. Si vous avez des idées, si vous avez un produit que vous voulez montrer ou autre, n'hésitez pas à faire vos propositions. On est toujours à l'écoute des idées. Voilà, donc ça c'était pour le côté au niveau du Jug. Sur la partie Java, vous avez peut-être un gros point que vous avez vu cette semaine, c'était notamment les les 25 ans de Java, d'existence de Java. Donc effectivement, ça commence à devenir une vieille dame. Et ce qui est intéressant, c'est que malgré ces 25 ans, Java se modernise, continue à évoluer à travers les différentes versions. Et cela se montre encore avec le JDK 15, qui est à notre disposition, qui est en préparation. Il y a des versions qui sont déjà en accès, early access, qui sont disponibles, avec une mise à disposition donc qui est prévue, comme on est habitué, en mi-septembre au niveau de la disponibilité. Et ensuite, on va retrouver les fonctionnalités qui sont déjà ciblées et prévues pour cette version. Et on a notamment les 2 garbage collectors qu'on avait pu évoquer, GCC et Sheldon. Et puis après, on a aussi d'autres éléments qui sont des évolutions par rapport à des éléments, des améliorations sur les records, sur les pattern matching of extension, instance off, et qui montrent effectivement qu'il y a une seconde review. C'est justement tout l'intérêt par rapport à ce qui a été mis en place sur les releases de deux fois par an, et avec un système de preview de l'incubateur qui permettent de pouvoir mettre en place un certain nombre de fonctionnalités et pour que la communauté puisse tester, faire des retours, un feedback avant que ça puisse être totalement figé et pouvoir revenir pour pouvoir corriger tel et tel point. Donc on aura l'occasion dans les prochaines sessions, je vous ferai un focus sur notamment les différences et ce qui peut nous intéresser dedans. Voilà, donc comme je vous l'ai dit, je vais faire court puisqu'on a quand même une communauté la cible n'est pas forcément pas uniquement français ce soir, mais beaucoup plus large, donc je vais faire court. Et donc je remercie les partenaires et je vais passer la main à Geoffrey. Et encore merci d'être venu.
Merci Lilian. I didn't understand everything, but the part about du vin et du bière, that sounded interesting. And the other parts too, of course. Let me try to share my screen. Here we go. So there's a small echo, just to mention it. So tonight I'll be talking to you about artificial intelligence on Quarkus, and more specifically about planning artificial intelligence. So and it's one of the best kept secrets in AI, I would argue. And it's also one of the most profitable technologies in artificial intelligence, I would argue. And I'm going to build an application from scratch. So the application that I will be building from scratch is a school timetabling application. Just 1 second. Lilian, there's a small echo coming from your side. From somewhere. Would you mind muting? Or unless you have a question, of course, or something. Yeah. Okay. So school timetabling. The application that I'll build for you is this application. So in this application, we're going to assign these lessons, such as English, math, physics, and so forth, to a time slot and to a room. And we're going to try to do that as optimally, as efficiently as possible. So here's the problem. We have a number of lessons, which we can see here on the side: math, chemistry, French, history. And we need to assign each of these into one of these slots. So for example, we could assign the math lesson in room A at 8:30, right? Now, the problem is that some of these lessons have constraints among each other. So for example, the math lesson and the chemistry lesson actually have the same students, the same group of students, the same class, so the 9th grade in this particular case. So those two lessons cannot happen at the same time. For chemistry and French, they are different students, but they have the same teacher, Marie Curie in this particular case. So they should also not happen at the same time. And again, between French and history, they have the same students, this time the 10th grade, so those should not be happening at the same time too, right? So what we're going to do is we're going to give this input into our AI constraint solver, and that will tell us, okay, you should be teaching math at 8:30 in room A, and so forth. And as you can see, Math and chemistry will not be at the same time. Same thing for the 10th grade can attend all of their lessons. And between French and chemistry, you can see the same teacher, Marie Curie, but she will not have to teach 2 lessons at the same time. So that's the application that I'll be writing from scratch today in Quarkus. It's important to realize that this is just one of the many planning problems in the world. The world is full of planning problems, and you can solve all of these with, for example, OptaPlan or any other constraint solver, of course. So one of them is the equipment scheduling problem, where we need to assign hospital beds or CAT scanners or rental cars to persons or to reservations, right? And we decide which reservation, which admission into a hospital which patient gets which bed. And by improving that efficiency, we increase our utilization. Another case is the job shop scheduling problem, where we need to, for example, build furniture or build cars or build books, and we need to do, creating furniture consists out of multiple steps. And these different jobs, they depend on each other. Some of them need to be done sequentially, other can be done in parallel. And we have a limited amount of people and machines and so forth to do this, limited number of assembly lines. And again, we want to do this as efficiently as possible to reduce the make span. So the make span is the amount of time it takes to create, for example, to publish a new book, to create 1,000 copies of a new book or something like that. By far the most interesting problem, I would argue, is the vehicle routing problem. Why? Or at least the most profitable, let's put it like this. Why? In this problem, we need to we need to visit a number of locations across the country, right? And the interesting thing is that we need to choose for each of these locations which vehicle, which driver will go there, and we need to decide in which order those drivers will go to these locations, right? Which are the black dots on this particular example there. By doing that more efficiently, we can actually reduce the driving time. And you might be surprised on how much we can reduce the driving time. We actually had a case with tens of thousands of vehicles. And it's not just for last mile delivery, like delivering something which you order on an eBay store, maybe Amazon or something else, and deliver that to your homes. But it's also, for example, sending technicians to people's homes or to locations across the country or to companies. It's, for example, telco technicians or technicians who fix kitchen appliances or things like that, right? Now, anyway, we did this for a case for tens of thousands of vehicles, and what happened is that they presumed by optimizing this, we could do it 1 or 2% better. So we do the same thing in 1 or 2% less driving time. It was actually 25%. So Van sank, right? 25%. That was a huge difference. Because the driving time went down so much, it really increased the productivity, the amount of time that these Swiss technicians in that particular case could stay with the customers, as well as it heavily reduced the fuel consumption, so the ecological footprint of these of this company, right? And they actually reduced it up to, and both of these led up to hundreds of millions of dollars of revenue savings per year, as well as tens of millions of kilograms of CO2 emission reductions, right? So it's good for the environment too. Another use case is bin packing, for example, in the cloud, where we need to assign processes to machines as efficiently as possible, again, improving utilization. And one of my personal favorites is the employee rostering cases, and there are many more of these. There's thousands of types of planning problems. I'm just showing you 5 of these. But in the employee rostering case, what we want to do is we want to assign shifts to, for example, nurses or guards or doctors or anybody who's not working 9 to 5, anybody who has morning and late shifts and maybe even night shifts, as you can see here. And we want to take into account their desires. For example, when they want to be free on Monday, the second nurse wants to be free on Monday, we want to make sure we don't have to assign her a shift on that day. And we take into account things like skills, affinity, and other types of constraints to make sure we get the most optimal schedule. Now, Like I said, today we're going to look into a school timetabling example. That's the one I'll build from scratch, and I'm going to use, this is the architecture I'm going to use. So I'm going to set up a Quarkus application. I'm going to add a REST service on top of that, which gets exposed through JSON to a UI client. I'm going to use Hibernate to go to the database, put it in a plain old-fashioned relational database, and I'm going to use OptaPlanner to optimize that schedule, of course. So it's time to get started. It's time to do some coding. So first things first, let's set up the Quarkus application and let's add a REST service. So the best way to start a Quarkus application is to go to code.quarkus.io. So I'm going to do that right now. This is code.quarkus.io, and I'm going to just generate an application here. The group ID is good for me. I'm going to use Maven, and I'm going to call it timetabling application. In this timetabling application, I would like to use Jackson because I want to expose my everything to JSON to my client. I want to use Hibernate, but I want to add Panache into that, which I'll show in a minute, but it's basically gives you a whole bunch of boilerplate code out of the box. And I want to use an H2 database, in-memory database, just to keep it simple, right? On top of these, I also want to use OptaPlanner, of course. So let me scroll down to OptaPlanner. Unfortunately, that isn't on the top yet. I'm going to add OptaPlanner here, and I'm not sure that it should be on the top, but it's my project, so I would love to see it. Anyway, I'm going to add OptaPlanner and also OptaPlanner Jackson integration, because we'll be sending something over to the UI too about how good the schedule is, the score, and that's where we could use this extra module. So I think we're done here. So we're going to generate that, and here we go. We have generated this application. I'm going to open it, and I'm going to extract that zip file to just my demo file here, which is empty, as you can see. It's extracted now. So here we have my timetabling application. So this is what the code.quarkus.io website gives me. What I'm now going to do is I'm going to open that in IntelliJ. So I'm just going to look for that project, which is over here in the timetabling thing. Here we go. We open that, and it's opening. And what we can see here, let me close this down. All this refreshes. This takes a bit longer than usual. Okay, here we go. And what we see in here is, so we get an application. There's a POM file in there, of course. In this POM file, we can see a couple of things in here. One of the things is that by default, it uses Java 11. I'm going to prefer to using Java 8 today, so I'm just going to change this to Java 8 for a minute. And what else we can see in here is using Quarkus 1.4. Okay, this looks all good. And you can see here it's already added me those things I selected earlier. So it added for me REST Easy with the Jackson integration, as you can see. It added to me Hibernate with Panache and the H2 database, as well as the OptaPlanner bits. The OptaPlanner bits, I'm going to just disable them for now. We'll enable them later in this presentation. I'm going to import this. And more specifically, I'm going to open the terminal. And what I'm going to run is the, let me hide this. What I'm going to run is, I'm going to run the Maven Quarkus dev command, right? So let me just run that over here, Maven Quarkus dev. And this is going to open on localhost 8080 the application for me, so I can take a look at what's in there. Now, what you'll see is that while I'm developing, while I'm adding things, adding a database, adding dependencies and so forth, I will not be restarting this application's Quarkus dev thing. So if you now go to localhost 8080, you can now see that the application is running there. And this is a static page there, which you can find over here in sources, main resources, and in the mid-env resources. That's that HTML page I just showed you. But more interestingly, if you look into the Java or Acme directory, you find an example resource. And so in this example resource, which you can see here, is this is a REST service. This is using JAX-RS annotations. You can also use the Spring version of these, by the way. And Anyway, this exposes a resource on the hello pad, and it returns hello. So let's take a look if we can see that over here. So we go here to hello, and we can see that over there. And if I now change this to goodbye, and I switch to here and I press refresh, I can see it is goodbye. Notice how quickly that changed, right? So notice it didn't take 3 seconds or 4 seconds to refresh. I didn't have to save or anything like that. I just went hello, I changed it back to hello, go over here, and I refresh, and I get the thing. This is developer joy. This is really, really beautiful. This is one of my favorite things actually in Quarkus. Now, so I'm going to build a timetabling application. So let's rename this, right? So let's rename this into a timetable resource. This is going to be a timetable resource. Let's also change the tests. In fact, I'm just going to delete the tests. You should be writing tests, of course. I should be writing tests, but for today, just to save some time, I'm not going to be writing tests. So now I have a timetabling resource here. I'm going to wait for the timetable. This is the URL where you can add this REST service. And this is going to produce not plain text, but JSON, and it's also going to consume JSON, right? So it's going to really communicate back and forth with JSON. Here I'm going to make a method that will return the timetable. So get timetable. So we're going to do timetable here. Now we don't have this class yet, so we need to create it. So let me do new timetable over here. And let me simply create that class. I'm going to create it in domain, in a new package called domain. You can see I've created it here. This is my timetable. And just to make Jackson happy, I'm going to add a string name here and add a getter for that, right? So that we can actually send this back and forth to JSON. If you now go back to the application and we ask hello, refresh, and this doesn't exist anymore. But notice how Quarkus in development mode clearly tells me, look, there's a REST service over there. So let's ask the /timetable. And you can now see we get back this timetable with name null. Okay, that's a good start. So next thing we need to do, of course, now is actually define our domain objects, the things which are specific to this application. And so what do we need in this application? We need a time slot, right, which is when a lesson will happen, right? So that will be in a day of a week, like Monday, Tuesday, Wednesday, right? A start time, like 8:30, an end time, like for example 9:30 if it takes an hour. So that's the time slot. The other class will be the room, which will be, for example, room 1, room 2, or room A and room B and room C, right? Which will have a name. And of course, we need a lesson class, which will basically say like the math lesson or the French lesson, right? So the subject is math, French, and so forth. There's a teacher in there. For example, Marie Curie was one of the teachers, if you remember. And then the student group in the 9th grade, the 10th grade, and so forth. Now, the thing is that these lessons will need to be assigned to a time slot, which starts out as not assigned, as null, and to a room, which also starts out as not assigned, as null, right? So let's start coding these things. So I'm going to go back to the application here. In my domain class, I'm now going to add a time slot class. So we're going to say, okay, we're going to give this a database ID, just as a long this time. Of course, you can use other things. And then I'm going to give, this will have a day of week. Of course, I am using Java time for this. Don't use Java util date anymore. This is much better, the Java time API. And so the day of week will be either Monday, Tuesday, Wednesday, and so forth. And then I'm going to also have a local time, which when it starts. In a more elaborate example, I might use zone times or something like this, but for this particular case, it's more than enough just to use local times. We don't need time zone logic in here for now. And so that's the time slot class. Now, for Jackson, I need an empty constructor, so I'm going to add that. For my test data that I'll generate later, I need a constructor where we'll fill in all of the things except, of course, the ID, which will be generated by the database. And because this is Java, of course, I want some getters. So let's add the getters too. Okay, so the getters are just generated too. So that's our time slot class. Next class is the room class, if you remember. So let's open the room class. Now the room class has, again, this database ID. And each room has a name, right? So we're going to again create a new R constructor for Jackson, for the JSON, so we can bring this to JSON, and we're going to create a constructor which accepts the name when we want to start creating our test data later on. And then, of course, a few getters for these two things. So now, if you look at it, we have our time slot and we have our room class. So now we need to make the lesson class. So let's do that. I'm going to add a class for the lesson. So what does a lesson have? Surprise, surprise. It again has a database ID. And it has a subject, which is a string. All right. And it has a teacher, like Marie Curie, for example. So the subject might be math, French, or chemistry, or things like that. And it has a student group. I would want to call them a class of students, but class is a reserved word in Java, so let's just use the word student group. Again, an empty constructor. This time, the empty constructor is not just for Jackson, also OptaPlan will actually need an empty constructor here as well. Later on. And again, we want to have something where we generate all of the fields and a getter for all of these things. Now, if we look back here, we do see that the lesson has a time slot and a room. So if we look in the code here, we're actually missing something. We need a time slot here, and we need a room here. Now, in a more elaborate example, I might have actually made this teacher not a string, but actually a teacher object, the student group not a string, but a student group object, which would be interesting if you need to know the size of the student group for some of the constraints and so forth. But today I'm going to keep it simple, and I'm not going to do that, right? These time slots and these room will start out as NULL, of course, because we're not initializing them here, right? And of course, we need some getters for that. And because OptaPlan will need to change them later on, I'm also going to create some setters for the time slot. See a set time slot and a set room too, right? Okay. But still, our timetable resource here gives back a timetable. So all of this needs to be added into this timetable. I'm going to remove this name thing, which I added just to please Jackson. And instead, I'm going to have here a list of time slots, all right? So, and this is of course a Java util list, and this is a time slot list, right? This is a list of all our time slots we can choose from, and then we need a list of all of the rooms that we have in our database, and then we need a list of all of the lessons, at least for the high school or the school that we're looking at, right? So this is the list of all of the, for one particular school, all of the time slots, all of the rooms, and all of the lessons. Again, we need an empty constructor for Jackson, but as well as OptaPlan in this particular case. And we want a constructor for our test data later on, or not for our test data, just to return it in a minute. And of course, we want a getter on all of this. Okay, so let's take a look here. So we have our timetable. And if we return nothing, we just return this where all of these fields are null. So it's time to go back and check what we have right now. If we refresh here on the timetable URL, what do we see? We see that the time slot list is there, the room list is there, and the lesson list is there, but of course they're NULL. Right? Okay. Now that's not really pretty, right? I want to show you something pretty, but this really is not really pretty, right? It's just JSON. So I should be writing a UI for you right now. Now the thing is, I like Java, and so what we're going to do is, of course, we're going to use JSON to expose this to the UI, and the UI of course, will be written in JavaScript, because a web UI needs to be written in JavaScript, of course. You have a couple of languages can compile to that, but I wanted to keep it simple here. The problem is when I write JavaScript, there's a couple of things I don't like in JavaScript. I prefer Java more, the typing and so forth. So when I do that, something like this happens when I start live coding in Java. I start saying things that should really not be recorded in a live session or shown on YouTube or anywhere else, right? So I'm going to skip this part right into JavaScript. So I'm going to take a little cheat here and actually skip this part. So I'm not going to do that in public. So what I'm going to do instead is I have a couple of I have a JavaScript UI here already. So a JS file, an HTML file, and of course the OptaPlan logo to make it pretty. And I'm going to drop that over here, over the index file that's already there. I'm going to save that. I'm going to override these. You can see now I've just added these three files, JavaScript UI, the HTML, and so forth. And when we now regenerate that, what you'll see is, if you now go to the root, right, the end of the linkers page, you can actually see that here. And my UI is caching something, which is interesting. Because what I didn't, so this is when I would actually open, let's say, an incognito or something like that. What you would see is you would get this. And then the reason for this is because I'm also using a little bit of Twitter Bootstrap and so forth. So what I'm going to do is I'm going to show you this. This is the POM file. I want to use a little bit of Bootstrap, a little bit of jQuery, a little bit of Font Awesome, and Moment.js in my UI. So what I'm going to do is I'm going to copy these, and I'm going to throw these dependencies in my POM. Now notice at the top, at the bottom here, we have Quarkus dev running, and I'm not going to touch that at all. I'm simply going to go to my POM, add in these dependencies, right? Go back to my here incognito one where it failed, right? Refresh. And let me take a look. I need to import here, I guess. And then when I refresh this, you can see that it's now working correctly, right? So now I get the pretty UI. Now I'm going to go back to my normal one where I did have it cached. Refresh it here too, just to show that it's working there too. Okay. So we have our UI, but we don't have any lessons yet to assign. We don't have any time slot yet. We don't have any rooms yet, and these buttons don't work yet. Neither does the solve button. So it's time to implement those things, right? What I'm just going to do for today is I'm going to actually just generate. So I'm going to add a Java class, which I'll call which I'll put in the Bootstrap thing, and I'm going to call this a demo data generator, right? So in this class, what I'll do is I'm going to add a method, which is called generate data. And in this method, I will, during the startup, generate some test data. Before we can do this, of course, I need to do something else. Yes, before we can actually do that, I need to actually add a database. Right. So I've added dependencies already, H2 and so forth, and Hibernate is in the class path already. But I need to now hook this up, right? So let's do that. Let me go back to my code before we actually generated the demo data. So what I'm going to do is I'm going to go to the TimeSlot class. I'm going to first make sure that this goes into the database with JPA. So what I'm going to do here is I'm going to say this is an entity, Java persistent entity, plain old school entity, but I'm going to extend the Panache entity base, which means that things like storing this and giving a list of all of the timestamps is very easy to do because there's methods for that on that class. What else I'm going to do is, what else is this ID needs to be known as a database ID. So this is the @ID, of course, and this needs to be generated through the strategy of auto, of course, right? So let me just make sure that, yeah, so this means that the database will generate this ID value for me once we start creating test data. Now, this thing, I'll just copy that. So in the room, the same case, we're going to make this a typical JPA entity, right? Stored in database with hibernate, extend the Panache entity to get the methods there, and make sure the ID is generated by the database. As for the lesson, same story there. This is an entity, extends the Panache entity base, so we have methods to find and store these lessons, and the ID is generated by the database. Here, of course, this has a connection to our time slot and to our room. So we need to add many-to-ones or one-to-ones or ones-to-manys in here. So let's take a look what that needs to be. Well, any lesson can be, any lesson will be in exactly one time slot. So it's a 2-1. But one time slot will actually accommodate multiple lessons, hopefully from different teachers and different student groups, of course, right, in different rooms. So this is a many-to-one relationship. And this is for the room, the same principle. One room can have multiple lessons, just not at the same time, of course, right? So room A might have one lesson at 8:30 and another lesson at 9:30, right? So again, a many-to-one relationship. Now, to make sure that these things go into the database correctly, we need to tell them in what kind of database and so forth. So what I'm going to do here is to tell Quarkus, okay, Quarkus, please, the data source, the DB kind is H2. So I'm going to store it into the H2 database. I need a JDBC URL also. So I'm going to say, okay, JDBC H2 in memory database, please. And it's going to be, I'm going to just call that database timetabling. And when it starts up, I also want Hibernate to generate the tables for me. So I don't want to have to go into the database and say, okay, this is the create a table or create a column and all that kind of stuff. So I'm just going to say generation is drop and create. So when we now refresh this, let's see if this works. All right. Here we go. We get an error. I clearly did something wrong. I did not define the URL. Notice how, by the way, Quarkus reverts the caused bys and puts the most interesting thing at the top. So the URL is not defined. So let's take a look. What did I do wrong there? I said JDBC. This needs to be data source, of course, instead of data thing. So here we go. We refresh this, and now I'm connected to the database. Great, but we still don't have any test data, right? So I started a moment ago. I started writing this demo generator. Let's continue with that. So what it needs to do is, when the database starts up, when the application starts up, I need to listen to the startup event. So this is called a startup event from Quarkus. And if I listen to this event, I need to say I'm going to observe that, observes. And then when it starts up, it will call this method. I only need one of these, so I need to make this an application scoped thing. This is just creates one data generator, one per application, and then when the startup event is observed, it will call this method. In that method, I'm going to add some things into the database, so I need to make it transactional, of course. Okay, now I need to add here a whole bunch of data. So I could say, for example, like room.persist new room, and then, for example, room A. So I could do this, right? And continue like this. However, that will be quite some code that would be boring for you to look at. So instead, I've also prepared it over here. So here I have some test data. Let me just copy that in and explain to you what this test data is. So I'm going to just copy this in. I'm going to resolve the missing classes, of course, an area list, day of week, and so forth, local time. And what else do we have here? The lesson import class. Here we go. Right. So what I have here, just to show you, I'm going to add 10 time slots, 5 on Monday, 5 on Tuesday, starting from 8:30 to 9:30 and so forth. The first lesson. I'm going to add 3 rooms. And I'm going to add a whole bunch of lessons, 20 lessons in total. So 10 time slots, 3 rooms, 20 lessons, right? And you can see, of course, Marie Curie is in here, as she needs to be, right? So let's take a look. I'm going to refresh the application. Something probably went wrong. Let's take a look. Why didn't it recall this data generator correctly? Did I import the correct observes or something like that? This all seems to be fine. Let's take a look again. Okay, this is interesting. So let's put, I'll just do it the old-fashioned way, put a hello world in here and refresh it. See if it actually picks it up. No, it doesn't pick it up. So this is not being called. So let's take a look. So this is the fun part about the live demo. This does work normally just out of the box. I'm sure that's not the case, but I just want to make sure that if I restart the dev mode, because I know it restarts from scratch, so I would be very surprised if this fixes it, right? There you go, it's starting it up, it started up. Yeah, no, as I expected, there's really something wrong in my code. The startup event is... Okay, I'm not going to try to figure this one out. I'm going to have to call an aid line here and just go into the actual application. By the way, this is the full example when I'm done with this. And so you can actually download this and play this yourself. I'm going to just in here, just copy these for a second. And let's see if I did something very wrong here. This one and then this one. Okay, so that looks pretty much the same, right? Weird. Let's see. And let's refresh again. And still no test data. I know what the problem is. No. Times it persists. Okay, this is interesting. I have a backup plan if this doesn't fail, but it's more interesting to look into why this is not being called correctly, because I must have something wrong in either the startup event or in the things over here. So let me just make sure I'm using the correct imports, and that all seems to be the case. No. So what we're going to do is, I have a backup just after this moment, so I'm going to just switch to that. So what I'm going to do is I'm going to take this timetabling thing, which is timetabling 2, right? I'm going to copy this into the demo directory, paste it, and I'm going to open that for you. I'm sure if I had some more time, I could figure this out, but I don't want to waste too much time on this. So I'm going to open this one over here. And the old application, the one that didn't work, so I'm going to close this one. And the first one, when I'm going to stop the Quarkus dev there. And let me just start this one here. Maven Quarkus dev. This one starts up. And once this is started up, and it must be something stupid, because right before this presentation I did this and it all, I must have something important wrong. There's always, live demos are always interesting, right? But anyway, this is the application just after we added that test data. So what you can now see is we have the unassigned lessons here at the bottom. We have math, physics, and so forth. You can see 2 math lessons by Ellen Turing for the 9th grade. And what we now want to do is when we click the solve button, we want this to, of course, solve the problem with artificial intelligence for us. We want to, in this case, we actually want to add the planning stuff to it. So I'm going to close the old thing here. So this is timetabling 2. The structure is pretty much the same. And what I'm going to now do is add AI planning optimization. So what do we need to do? We need to add OptaPlanner. And when we add OptaPlanner, we need to tell OptaPlanner what it can change for us. So which decision that the artificial intelligent planning algorithms can make for us. Can it, for example, say, I want to use a different day of the week for a particular time slot? And of course, it cannot, right? That's input. We decided in advance which are the time slots, which are the rooms, which are the lessons. The only thing that actually can choose for us is for each of these lessons, the time slot and the room. Right, so for each time slot, it can pick which time slot and which rooms. So those are the planning variables. Those start out as NULL, and after we give them to OptaPlanner, they will be assigned to an actual value. And of course, depending on all of the other lessons. So if we give it 20 lessons or 2,000 lessons, it will make sure that no 2 lessons happen at the same time, right? Or any other constraints we will then, of course, program in a minute. Now, anything that changes during planning is a planning variable, and any class that has 1 or more planning variables is a planning entity. So that's why the lesson needs a planning entity here. So if we jump into the lesson class over here, we are going to now, let's just add this. Now, before I do, I first need to make sure that OptaPlanner is active, of course. So I'm going to just activate OptaPlanner here. You can immediately see that Quarkus is picking up on that. Will actually give us an error on that because by default, OptaPlanner wants to see something that has a planning entity in this current version. So because we don't have that yet, it will complain. No worries, let's do that. Let's add the planning entity annotation on the lesson class. And let's say, okay, what can it change? So what can the AI algorithm change for us is the time slot and the room. So what we're going to do here is we're going to say this is a planning variable, changes during planning, and the room is also a planning variable. Now, OptaPlanner cannot simply create a time slot and assign it to each of those 20 lessons. It will have to pick a time slot from one of those 10 lessons we've defined in the beginning, right? So from somewhere, it will need to get a list of all of the planning, of all of the time slots. So what we're going to do is we're going to say, okay, there's a value range, that's that time slot list it can pick from, and we're going to call this a time slot range. That's a value range provider. And later we'll actually connect this ID to somewhere where we get a list of all the time slots in our data. And the same thing, of course, for the rooms. We cannot just create rooms out of thin air. We want it to have pick one of the 3 rooms that we define in our test data, right? Now, which object has a list of all of the rooms and all of the time slots? That's, of course, our timetable over here. That has a list of all of the time slots, all of the rooms, and all of the lessons. Now, we also need to give something to OptaPlanner to solve and to return, which gives us the solution is to look, here's a list of all of your lessons, all assigned to a room and to its time slot. And we're going to reuse this object for that. We're going to say this is a planning solution. This is something that OptaPlanner, this is one data set we give to OptaPlanner to solve one high school, one school to solve one tenant, right? So this has a list of all of the lessons that can change. For that, we need to tell them that's our collection of planning entities, right? So OptaPlanner gets this object and it will then get all of the lessons out of this and start solving to optimize those lessons and assignments. Like I said earlier, we need to get a list of all of the time slots for it to choose from. So this is that value range. So this provides this value range. And this is, of course, that time slot range. So if you look into this time slot range over here, that connects to this time slot range over here. So to fill in for each of the lessons a time slot, it picks one from this list. Same story for the room, the room range. Okay, once OptaPlanner has actually solved this timetable, it will also be able to tell us what the quality of this timetable is, how well it is planned, and it does this by giving it a score. And this is a hard soft score. There's actually multiple forms, but in its simplest form, it's a hard soft score. And of course, OptaPlanner again will need to know, here's the score element, and this is an annotation just to know that it can change that, right? So now we have our domain ready. So we have these planning entities and planning variables in place. The solution is usually just pretty straightforward. The hard part is actually figuring out what changes during planning. Once you figure it out, everything else usually falls into place. So we have our REST method over here. We have our getter over here to get the timetable. But what we don't have, and this of course needs to be a transactional method. What we don't have is we don't have a solve method yet. So we're going to have a solve method here. Let me just throw unsupported operation exception here just to prove it to you. And if we now go to the UI and we refresh and we click the solve methods. Oh yes, of course. I need to add one more thing for OptaPlan is the actual constraints. I need to tell them what do we want to optimize. So I'm going to add a time table constraint provider, and that will include all of the things we want to optimize. So there are the constraints. So I'm going to say this is a constraint provider, implement that one method, which is a define constraints list. And I'm going to say return me a new constraint list that's empty. So no constraint so far, right? And when I now refresh over here, you will see that remember we threw, when we click the solve button, it will actually throw that. Let me check here to go over here. There's no, this needs to be a post. We need to extend that. We need to expose it as a post method on the path solve, right? And if we now go to over here and we click the solve button, we get an error. It's a bad day for, oh yeah, I stopped it apparently. Quarkus dev apparently, anyway. We do a refresh over here. And let it start up. This is just the dev mode starting up. Right, and when we click the solve button, we get that internal server error, of course, because of that unimplemented method, unsupported method over here, right? Now let's implement it. So we have everything we need on the OptaPlanner side. We have the model, we have the constraints, no constraints yet, but at least we have a definition that there are no constraints. But the thing that we're missing, of course, is the actual solving. So to do the actual solving, what we're going to do is we're going to say, okay, give me a solver manager for my timetable, please. So for my timetable object. Average solver manager also has a type of a problem ID. That's basically a tenant ID, or it's when you want to solve multiple tenants in parallel. In this case, we're going to keep it simple. So I'm just going to have a long there, and I'm always going to use the same long, as you'll see in a minute. I'm going to inject this or auto-wire this, depending on where you are, of course, as a platform. And now I have this solver manager, and I'm just going to say, okay, when I get the solve method, solver manager, please solve and listen. So what does that mean? It means solve a problem that I'm going to give you. And I'm going to say, okay, I'm going to give this problem ID 1, which basically means, like I said earlier, we were just going to hard code that on one problem ID. And then I'm going to give a method which, given a problem ID, returns the timetable. And as we don't have multiple tenants in our database, we just collect all timestamps, rooms, and lessons, and that's our timetable. I'm just going to connect it from over here to this timetable method. One more thing I need in there, and that's an actual save method. So given a timetable, I need to save that timetable, right? And I'm going to create a method for that over here. I'm going to make that public method and make it transactional. Interesting thing about Quarkus is that if you have a method like this, which is transactional, and you call it from the same class, it is actually transactional, right? That's a really nice thing, I think. Yeah, of course, we can replace this with a method reference, right? So here we go. So when we get the timetable there, we're actually going to solve it to. So save it to into the database. So how does it happen? We're just going to iterate across the timetable's lessons. Just go over all of the lessons. We're going to ask the the lesson which is attached. These are actually detached lessons for those who are familiar with JPA. So I'm going to ask lesson get ID, return me the attached lesson for this for that ID, and then I'm simply going to say attached lesson, set the time slot to the lessons time slot, and set attached lesson, set the room to the lessons room, right? So I'm just going to, when I call the save method over here, I'm going to just store the assigned time slot and the assigned room into the database. So what does this method do, this solve and listen method? It solves this problem that it fetches from here, and then every time it finds a better solution, it saves it into the database. And as you give it more time, OptaPlan might actually find better and better solutions, especially when you have many constraints and the problem is difficult to solve, right? So let's take a look at what we have right now. So remember our constraint provider. How many constraints do we have right now? Well, actually, let's click the solve button, right? Let's see what happens. So OptaPlan is solving it for us, and OptaPlan assigned all of the lessons to room A into the first time slot. And why is that? Well, very simple, because when we look at the constraint provider, there are no constraints. So OptaPlan says, I'm allowed to put all of the lessons in the first room at the same time. There's nothing preventing me from doing that. So now it's time to add some business intelligence to this case. So we're going to say, I'm going to add something called a room conflict. And I'm going to say, okay, every time you put two lessons in the same room at the same time, we have a problem. There's multiple ways I could implement this. I could implement this with an easy Java score calculator in OptaPlan and just do some iterations across the lessons and so forth. But the problem with that is that it's not incremental, and it doesn't use indexes and hashing to do this far more efficiently, far more faster. So instead, I'm going to use our constraint, our functional API. And what this does is it's really very much like an SQL query. So what I'm going to say is, give me a lesson. Right. And then join with another lesson. So give me two lessons. And then I'm going to say, I'm going to penalize that I don't want those two lessons to be scheduled like this, right? So conflict. And when it does, I want that to be violate a hard score. Right? So that's not good enough, of course, because that will be any two lessons, and of course, and that won't change. But I specifically want to check if those two lessons are being assigned to the same room at the same time. So what I'm going to do is I'm going to say in the joiners, and you can do this with a filter too, with a predicate too. But if you do it like this, it actually uses indexing and hashing to do this much faster. And I'm going to say, if I have two lessons in the same time slots, and if those two lessons are also in the same room, right, then I have a problem. So then I'm going to penalize that, right? So if I have a lesson, select from lesson, join with another lesson for which the time slot is the same and the room is the same, then you lose 1 hard point. Then I'm going to tap OptaPlan on the head and tell them don't do that, right? So let's see what that gives us. So we can do, we press the refresh button with Quarkus there, we click solve, and of course we can see it over here, right? So that's starting to look like a good schedule, right? We have one, we don't have two lessons in the same room at the same time anymore. Except, of course, if you look at it by teacher, because if you look at it by teacher, we're now seeing that Alan Turing over here has two lessons at the same time on Monday. Marie Curie also on Monday afternoon, she has two lessons at the same time. So again, we need to go back here and we need to add a teacher conflict constraint. So what I'm going to do is I'm going to duplicate this room conflict, call it a teacher conflict constraint. And that's pretty much the, I'm not a bit IntelliJ at this time. And that's pretty much the same constraint. Give me two lessons that happen at the same time and that not involve the same room, but the same teacher, right? And then we have a teacher conflict. Notice how these two lessons, these two constraints are very independent of each other. If we now refresh this application and we click the solve button, what we'll now see is that not just the rooms, every room has its own lesson, right? So no room conflicts, but we also have no teacher conflicts. Each teacher has its own lesson. If you look at the student groups, however, we still see a conflict there. We're asking some of the students to be in 2 places at the same time, here the 10th grade, for example. So again, we don't want that. And this is pretty much the same constraint all over again. Now it's a student group conflict. So we just ask if the student group is the same, and student group conflict. You're probably wondering, why do we give the string? Well, this is OptaPlan can also tell you, if you have a solution, which constraints it violates and how many times, and then the string becomes very useful, right? And it really helps you explain where it did not, where some of the hard or soft constraints are broken. Hard constraints normally not, but soft constraints are. At this point, you might also be wondering, what's the difference between hard and soft constraints? Well, up to now, I've only shown you hard constraints. So hard constraints are that you cannot teach two lessons in the same room at the same time, and you can see we have this fulfilled right now. You cannot have a teacher who has to teach two lessons at the same time. It's also a hard constraint. Things that must not happen. Soft constraints are things that you want to minimize. That can happen, but you want to minimize them, probably because they cost money or they make people unhappy or reduce the service quality. But if you now look at the student groups, you can see that this is now all fine, right? We have now all of the hard constraints fulfilled. Now, at this point in time, if you have to do this as a human being, create a schedule like this, especially for a larger school, you would say, okay, this is taking far than enough time to do, because this actually takes multiple hours to do, right? Doing just a room is easy. The problem is when you change something over here, when you say, okay, I want to switch this lesson with that lesson because it's better for the schedule, you break a room conflict constraint, right? It's like a spaghetti. It's a snowball effect. You pull somewhere, something else breaks. So getting this schedule is actually already quite difficult. It's already quite an intellectual thing to do. But OptaPlan can go a lot further, and we do, of course, right? We can start adding soft constraints. I won't be adding a soft constraint right now because we're running out of time, but I want to show you something. So I've just talked about hard and soft constraints. Soft constraints are things we want to do, avoid borking. I want to add a COVID-19 specific constraint, which is a hard constraint in this case. So what I want to show you is, in school timetabling, as kids are going back to school, one of the things they start adding is the rule that when you go through a hallway and that you don't go in the opposite direction. So there's a one-way direction to go through the hallway. So you can go from room A, you can attend a lesson in room A, and then the next lesson can be in room C, but you cannot have a lesson that starts in room C and then the next lesson go to room A, unless there is a break between those two lessons, unless there's a lunch break or another type of break in there, right? So here's an example of that. We have the French lesson for the 10th grade. Their next lesson is history. That's fine. They go from room A to room B. That's in the correct direction. But you see here that the math lesson, the 9th grade, goes from the math lesson in room B, has to go counter stream into room A, and that's something we don't want. So this is bad. In fact, we would rather just have this chemistry lesson in room C instead of over here, right? So let's see if we can actually implement that. This is the constraint for it. I'll just copy it and explain it in a second. But let me first show you that we're actually violating this constraint. So over here, what you can see is between 9:30, between the first and the second lesson, there is no break. So the 9th grade actually has to go from room B and then go to over here, room A in the second lesson. So they actually are going counterclockwise. They are violating this new constraint, of course, right? So if we now go into the implementation, I add this constraint, all right? The room counter constraint. Let me do that. What does this do? It says, okay, give me a lesson, join with another lesson. If those lesson has the same student group, if it's on the same day of the week, if the first lesson ends exactly when the second lesson starts, and if the lesson's name of the second group is greater than, I took the trick here, right? I didn't use a number, I just looked at the alphabetical order of the room names. I presume that those are in alphabetical order, then we have a room counter constraint violation, and we break it with 1 heart, right? And of course, in a more production environment, you would not just take the room name, you would do this clear. Notice how I can actually add a predicate in here, right? So this is just a normal predicate. I can call any Java code in here, and I can put breakpoints on that and so forth, right? So let's take a look at how that rolled out. Notice that here 9 grade went from room B to room C. If we now solve it, what we can now see is that the 9 grade starts in room A, stays in room A. In fact, OptaPlanner has decided to put 9 grade all the time in room A. Apparently, that for this particular case, with these particular constraints, was a good idea. In reality, however, once we start adding soft constraints, and one of the soft constraints, for example, will be that the teachers will want to be always in their own room. So Marie Curie always wants to be in the chemistry lab, for example, that you'll see that in chemistry lab might be room B or room C, that she will not be teaching in room A, of course. And that gives a far more, it's far more difficult to solve. And given more time, I will definitely show that to you. And if you actually check out the example and run this yourself, you'll see that OptaPlan solves that too. Right? So thank you for listening. If there's any questions, I'll happily answer them. If you want to take a look at the sources, if you want more information, you can go to the OptaPlan and the Quarkus website. If you want to build this, what I'm showing you from scratch, you can just look at this guide. And if you actually follow this guide, let me show you. You can also find the source code for that. Over here, you can scroll down. You can find the source code for that over here in the OptaPlanner Quick Start directory. So you can just check this out right now if you want after this thing and build it locally, Maven, Quarkus Dev, go to 8080 and play with it. What I haven't shown you today is the fact that that Quarkus can generate native images, which is just which means you have a native image, no more JVM involved, of course using the Graal technology underneath, and that gives you super fast startup times and so forth. I haven't showed that today due to lack of time too. Are there any questions?
A question in the chat room.
Yes, let's take a look. Let's see, what are the questions? Is it possible to add constraints dynamically by the user on the front end? That's a very good question. So adding constraints is always a little bit formal, right? It's very much if you do it with this case, we have a couple of other options actually, but if you do it like this, it's pretty much like an SQL query. So one of the things we notice is that one of the things we do a lot is that we have data objects that define our constraints. So for example, let's say we want to add a constraint in which when the lesson is assigned to a time slot and the particular teacher is in there, and we, for example, say Marie Curie hates Mondays for whatever reason. And so we want to then check if Marie Curie has a time slot is assigned to a lesson, has a lesson where the time slot is Monday, right? And you want to penalize that. You could write that specifically for Marie Curie, right? You could specifically write a constraint here that says, from a lesson filter where the subject is, so something like this, right? So it would be, let me just write it here. You could write from lesson its filter, the lesson get teacher equals, equals, and then Marie Curie, right? Now the thing is, when you write constraints like that they're not very dynamic. So you can make them far more dynamic by, instead of doing that, say, okay, I'm going to create a teacher day of week penalty object, right? Which basically says, given, so where you say, okay, class teacher hates day of week, right? And then you just say, okay, I have a teacher here, and I have a day of week here, or even a time slot. And when you have that, users can far more easily add constraints. Well, they're not really adding new types of constraints, but they can easily say, oh, for that teacher doesn't like that day, or for that teacher doesn't like that day. So that's the first thing you can do. The second thing you can do is any of the constraints we define here, you can actually give them different weights, and you can disable and enable them based upon the user's needs. So if you have, for example, a multi-tenancy application with multiple schools, one school might say this room counter stream thing is important for us, and for another school might say, I don't care about that at all. We're not doing that nonsense, right? So one will disable it, maybe even make it a hard constraint. The other might disable it or just make it a soft constraint, right? Same thing with having teachers have their own rooms, reducing the gaps between lessons, right? So one of the things that I see often is they want to avoid these gap hours between lessons for teachers, so they don't lose a lot of time at school, and they don't have to come multiple days to school if they can just do it in 1 or 2 days instead of going 4 days to school. So that helps a lot there too, constraint days. But actually adding completely new types of unformalized constraints is quite difficult. Constraints needs to be formalized, and formalizing is a form of coding. So you can go very far. You can give them a lot of freedom in adding constraints, but not just randomly things they can think of, if that makes sense. Let's take a look at some of the other questions. So is it possible to add? Yes. So does the order of constraints impact the final solution or the order of lessons? The order of constraints does not at all. So it doesn't matter if I would if I would change this, you will see if I run it again, I get the exact same solution. In fact, OptaPlan gives you out of the box reproducibility, which means if you run it twice, you get the same solution at around the same time, at the same amount of CPU time. You can turn it off, but most people don't. It's very handy for debugging and so forth. So the order of the constraint doesn't matter at all. So if I do this, this will always give the same solution. What matters a lot is, of course, the weight. If I would, for example, say this room of things is actually more important, I could say this is like weight 20 hard. So it's 20 times as important as the teacher conflict. That could actually affect the solution and the path it takes to find the good solution. To give you an idea, to give you an idea on how deep this problem is, here we have 3 rooms, 10 time slots, and 20 lessons. So that is actually 30 to the power 20 possible combinations. That's the number of different schedules you can make. OptaPlan can only look at a very, very small fraction of that, even despite the incremental calculation and the deltas and the indexing and hashing and so forth. It can look at maybe a couple of 100 billion of these solutions. And there is, in many cases, there's more than a Google or a Google squared solutions, right? So point being is that one small change in the weights can really give you a different solution, right? Especially if you have a lot of constraints, and there's many options there. Depending, of course, how long you solve. If you solve long enough, they will eventually. It might not matter that much. So when you learn about conflicting constraints at compile time or runtime. So conflicting constraints are either complementary or adversarial, which means some of the constraints help each other and some of the constraints fight with each other. To give you an idea, if you focus on reducing the driving time and vehicle routing problem, you will also reduce your ecological footprint. Those are complementary constraints. They will help each other, right? Just do stuff more efficiently. Other constraints are adversarial, right? If you, for example, say, like in this case, the fact that the room should not have conflicts and the teacher should not have conflicts, these two constraints won't help much each other. They will pretty much more fight against each other, and that's fine. That's just a OptaPlan will try to find a win-win situation, which it does here, where neither of them is violated. If there are soft constraints because they happen anyway, then they are weighted against each other, and then OptaPlan will find the one which, either you prioritize one or you weight them against each other. In both cases, OptaPlan will find the best win-win situation, taking that into account. Oh, is it another interesting question? Is it possible to lock one slot and let the AI fill in the remaining? Yes, it is. So the user should be in control, and this is a really good question. So what you simply do is you just say, okay, I'm going to put so the simplest form. There's multiple forms of this, but the simplest form is, so here we call it locked, right? So what you can simply do is here say, I'm going to call this a planning pin. And if you now add, maybe I can just do it. If you go to the demo generator, and I would take any of these lessons and just pin it to true, and assign it to a time slot and a room already, OptaPlan will actually respect that. Given that over time, I won't do it now, but it's very simple to do. Do try it out on the example. It's just adding a planning pin there and making sure that that particular lesson in the database already has a room and a time slot. And OptaPlan will fill in the rest. And as long as you didn't pin two lessons in the same room at the same time, OptaPlan will make sure that everything else works out fine. If you did, then it's going to give you a solution which doesn't break any new hard constraints except the ones you've already broken by pinning them in that, putting those two things in the same room at the same time. Is it possible to load data constraints via a CSV file? So for data, in some of the examples of OptaPlan, we actually get it from XML. I think one example might actually also get it from CSV. We have a couple which gets it from a POI through POI from an Excel file and so forth. But OptaPlan doesn't care, right? That's integration with other stuff. So where do you get your data from? If you, for example, would say I'm going to open a CSV file and parse my time slots from there, that's fine. OptaPlan simply doesn't care, right? Here it's coming from a database through JPA through Hibernate. Again, OptaPlan really doesn't care where it comes from, as long as when we call this this method over here, solve and listen, this thing needs to return something, a domain object. If this goes here, it goes to a database. If this goes to a CSV file, that's all. That's perfect. That works. What is the Iie algorithms behind the scene? Oh, the million-dollar question. So we have a whole bunch behind the scenes, but by default, there's two that are being used. First, there's a construction heuristic called first fit, and then there's a meta heuristic, specifically a local search algorithm called late acceptance. And we have a whole bunch behind the scenes. Let me just quickly show a list of the ones we have. And it's interesting to remember, so nowadays there is this hype. Oh, no, that's not the button I want to press. This is the blue button I want to press for the documentation. Nowadays there's this, hype is the wrong word, but there's a lot of interest in neural nets and machine learning. And these neural nets and these machine learning algorithms are great for pattern recognition. Planning problems are not pattern recognition. And in fact, neural nets are quite terrible, or inferior is the right word, to on these kinds of planning problems. They get like 1% improvements in vehicle routing, while constraint solving algorithms get 15, 25, 30% of improvement, right? So a list of all of the algorithms we have out of the box is over here. The overview. So there's a couple of exhaustive search, even a brute force. It's not scalable at all, and so forth, right? So you don't want to use those. And then we have a bunch of construction heuristics to find a quick solution, the first solution quickly. But this is not an optimal solution, not even a near optimal solution. And then we have meta heuristics, more specifically local search algorithms, more specifically things like late acceptance, tabu search, and similar needing to get to a better, a near optimal or optimal solution very quickly in reasonable time, even with, when scaling out to thousands or tens of thousands of planning variables and entities and so forth. If you want more on that, by the way, information on that in the manual, you can actually see an explanation of each of these algorithms. So like this is, for example, how the simulated annealing algorithm works on a very high level. Of course, this is just one of the orthogonal things we do. We combine this with far more other interesting aspects, such as the selection algorithms, probabilistic things, and so forth. I can talk multiple hours on that, but I'm not sure how deep you want to go here. Can OptaPlanner be used in production? OptaPlanner is used in production all over the world, and even there was actually a case for satellite bandwidth scheduling too that's in production for years. It's in production with in Fortune 500 companies, impacting the lives of I guess at least hundreds of thousands, if not millions. You know, there's a country where every single hearing is scheduled by OptaPlanner for the judges. There's telcos that use it to schedule every one of their technicians. So it didn't, you know. The interesting thing is if you add in the right constraints, you can really improve people's lives, improve service quality, improve productivity, improve environment. And then, of course, how you weight those against each other becomes interesting. But there's basically more pie to share. And then the question is who gets most of that pie, of course, depending on those different stakeholders. How do you go about incremental planning when only a few constraints for a large vehicle run change throughout the day? So there's two questions there. Can we do real-time planning is one question I hear there. And yes, we can. So can I show that very quickly? So we can do real-time planning, which means that I could probably just show that very quickly. So this is the actual old school OptaPlanner swing example. So you have to excuse me because, yes, nobody wants to see swing examples, I guess, but I'm going to run them anyway. And there I'll show you what real-time planning is. Once these starts up. So in real-time planning, it means that you have this perfect schedule you figured out during the night and you start it up, and in the morning what happens when it's in production, somebody says, okay, there's a vehicle that broke down, right? And it can't continue its tour, and we need to really go to those locations too. I didn't prepare this, of course, so it doesn't just boot up. But you have to trust me on that. If you try the vehicle routing example, maybe in a minute I can show you. But you can actually add locations in real time. Oh, I have a slide for that. I can just show the slide. It's better. Or not better, but at least it's something to show. Real-time planning on vehicle routing. So what we can actually do is, if this is time, what we can do is, we have a perfect plan before 8 o'clock. The vehicles start leaving to their first locations, and then at 8:05, a new customer is called, needs to be delivered to. We can actually change the entire plan if you want to. We can also add rules to not disruptively change the entire plan, but do that do the minimal amount of change to get back to a feasible plan where no hard constraints is broken. So yes, we can do real-time planning there. So yeah, and that's indeed incremental replanning. That is incremental replanning. It's not incremental score calculation. That's a different thing, which we also support, of course, which we actually use heavily, as we seen earlier. We can also deal with continuous planning, which means that continuous, and we can combine that with real-time planning. So continuous planning is when you have, let me just show it here. Continuous planning, here we go. So continuous planning is when you have this plan which changes. So you have a plan for the next 3 weeks, and then a week later or a day later you replan it. And so some of the parts got pinned or got history, and there's a new, and you have a planning window that's moving along as you go through time, right? So you can see here that the planning window, that's the orange thing, moves along as time moves further. And you can combine this with real-time planning. Right. I think that's the last of the questions. If there's any other questions, I'm happy to answer them. Feel free to join us on the OptaPlanner Dev mailing list, or if you have questions, or on Stack Overflow, I'm happy to answer questions too. And thank you very much for Lillian for inviting me. Oh, can OptaPlanner be used with Spring? Yes, it can. Okay. We have a Spring Boot Starter too. Just to answer that last question, we have a Spring Boot Starter too. Works pretty much the same as this one I showed you in Quarkus. Just the dev reload is, slower. Right? That's why I really love Quarkus. And you can do a native image that's there.
Okay, thank you, Jeffrey.
Yes. Let me close.
Yes. Thank you, Jeffrey, and thank you for all attended. And good night. And share link for this video conference. Thank you. Bye bye.
Thank you. Bye.